Welcome to clickmyproject.com. Our product title is a new XOR-free approach for implementation of convolutional encoder. Now we are going to discuss about our product abstract. We propose of novel algorithmic approach that find an XOR-free processing architecture for non-systematic feed-forward convolutional encoder. This process we are using the data transmission reliability and the two main requirement of modem 3GPP and 3GPP2 standards on unreliable wireless channels. This letters presented a new algorithm is constructed an XOR-free architecture and the approach for completely remove the XOR processing operations. This we are using the non-systematic feed forward generator polynomial and reduce the logical operators. Thereby we are using the encoding the processor and addressing and operations of the reduce the ROM size nearly 50% of the results architecture. And then we implemented the convolutional operations is realized using the deterministic finite state machines DFS. Is how implementation requires combinational circuits and memory elements. This decreased the valuation of encoder sequence and express the terms of information sequence. This process we assign the information bits as logic 0 for all possible encoder states whose next states follow the previous state incremental by 1. Compute the output port response using the basic convolutional process. The encoder output with it encoding the state in the arrangement of the tabular form. The group of the encoder states based on the Specialization encoder output. Split the encoder state element in the 32:1 in the mux the encoder, and then we are getting the 5 selection line bit. We are giving the input for the 8 bit, and we have selection line is a 5 bit, and then we are convert the encoder processor, so 30:1 mux processor, and then we get the 4:1 encoder processor again to the. So we are the first we are using, then we get the output from the ROM for the memory processor. So split the encoder state assignment the bit into the two subports. First one row tag and then most of the significant bits column tag. So we have assigned that, and then we are regain the full functional and ADU input for that response for choosing the polynomial using C code, and the code assumes the bit logic 0, the possible combination of S or state, and convolve with the compute the encoder process. So we are using the two separate subports for the mux encoding the processor, and then we are using the column and row wise that can get the processor store the RAM process. So we are this process we are getting the low power and maximum space for using the architecture of the project's ROM process. Now we are going to discuss about our product flow diagram. The product flow diagram, you select the input data for the 8-bit channels. The input for the 8-bit and the we have selected the selection line for the second. The selection line is code the 5 element and going to the selection mux logic. This mux logic get the two parts of the logic gate. The encoding process of the mux selection logics, we are separate the two parts 32:1 mux for the encoding process, and then 4:1 the encoder processor, and then we have collect the RT row and RT column wise we are get the memory wise process. So the architecture include of the SR with the K -1 memory elements of the multiplexer to decode the encoder sequence for the row. Here 32:1 mux is used to select a new RT from one its inputs is accordance or isoform of states. And then the second stage of the 2:1 mux is used to process the output of the mux is occurred in the input. The output of the second mux is combined with the CD coming the LSB bits of SR to get the final encode bits. The hardware cost of the above architecture that can be improved by the reducing the ROM size using the pre-processing logic. The logics form the observing the anti-systematic city relationship of the either even or add row pairs of ROM. The MSP of second stage mux and input bits are usually the development modify the logic from the logic reduce the 16 element ROM into the 8 elements which consume the lesser power and improve the propagation delay. The modified architecture of the 4:1 mux at the second stage of the process. The ROM based architecture can be reconfigured to modify polynomial of same constant length of the code rate. The algorithm is further tested in the generic polynomial process, and then we are getting the process in the row mux structure and XOR free mux controller. In this process we are using the removal the full XOR gate logics in the mux encoding process, and then the row mux process. The row mux process we are get the row wise and column wise the process in the reduce ROM XOR free elements at the time of the difference level of signals process. Now we are going to discuss about our running procedure for our project. So this is our tool for the silence, the ISE project navigator. So this is our main coding for this, the main process, and then this is 32:1 encoder, 4:1 encoder, and then memory allocation for ROM. So this is three parts we have considered to one process in the main consider, and then we have click that and then we have double click process, and then it show that simulink behavioral model. This is a right click, we have run the process, so run the coding, and then it's a message shown in a console. We have to get the output process output. This is the main function. All the functions are processed in the console. They get the output from here. The process simulated behavioral model is complete successfully. So it shows the output from here, and then we have designing process here. The implementation result. We have opened this process. It will be automatically open the ISIM process, the tool. This we have the consider from give the input and get the output from here. So now our process. This is the these all are the inputs: clock, reset, write, then the 8-bit process, and this is the output process. These are the temporary output process. This is the main output EROM process operations. So now give the value for the force clock. This is a clock, so we are giving the 0 and then 1, then periods for 1009 second. So apply and OK. This is on the reset the 4 constant. Give the input value for 1. Okay, and then write functions. So also 0. And then we are giving input for 8-bit input. So this is OK. And then so now run the process. This is running the 2. So this is a clock only 0, and then we have reset the value for so 0. Now the running the process, and then write also get the enable process 1. So now also run it. So this is the output for this. So This our process 10101010. This is 8-bit for the input selection. So first of all, main 10101. This is the selection file lines. This output going to the selection line for single 2-digit 00, and then remaining this one. This is the LSP is going to the reduce selection line 1. The last 2 digit we are giving the temporary process 101. We are allocating the temporary get the values. So now our process output this. The actually this the clock pulses, and then we are going to this process the implementation. Now we have run the process the simulation. Now implementation we are going to that. This is synthesis or schematic diagrams. So now our main process is the how to reduce the power consumptions. So we are right click the text report. So this is our process output for device utilization summary. So number of LUT is 2 and the logic is of 2 and the flip-flop is of 2. We all are using LUT is reduced from the base paper, and flip-flop also reduced it, and power consumption also reduced it. So okay. This process is implemented on a schematic diagram. Implement model descripts.